All right, open your packet to problem 4.1. It says tracking a ball. And you can also follow along in your book on page 56, or I've put the table right here so that you can see. The first question says, describe how the height of the ball changes over this 4-second time period. So if you look at this, the first thing you're going to notice is that it goes up until 64, and then it goes back down until it hits 0. And these happen to be mirror images. So these match up, these match up, these match up, and so on all the way back. So what we know is that this for sure is a vertex, and these are our two x-intercepts. So you could write that it starts at 0, and then it increases less and less, meaning that the first difference is 15, the next difference is 13, the next difference is 11. So it's increasing less and less, a difference of 9, a difference of 7, a difference of 5, a difference of 3, a difference of 1. Until it hits the vertex, which is at 264. And then it decreases more and more symmetrically, which means the same exact numbers, until 4 gives 0. So the second question says, without making a graph, describe what it would look like. Well, just so you understand, I'm going to make one. At 0, you get 0. At 4, you get 0. You don't need to plot every point. And at 2, you have your peak of 64. So this is your parabola. So the main parts are that it has two x-intercepts, which we pretty much wrote above. It has a vertex, which is a maximum point, and the line of symmetry is at x equals 2. And if you remember, 2, x equals is this vertical line, so that's your x equals 2 line. And the y-intercept is also at 0, 0. And number 3 says, do you think the data represents a quadratic? Yes. And that is because the graph is a parabola. In fact, it's a negative x squared because it's going down, because the vertex is a max. The next question is this. I'm actually going to go back and talk about how you personally could write an equation for this. So since 0 gives you 0, one of your factors is just x. And then since 4 gives you 0, the other factor is 4 minus x. This tells you that 4 gives you 0. This tells you that 0 gives you 0. So to figure out what the coefficient would be, what the number right here would be, you would pick the vertex as a great point to plug in. And if you plug in 2 times 4 minus 2, you get 2 times 2, which is 4. Well, you need to get 64. So if you multiply that by 16, you would get 64 because 16 times 4 is 64. So if you distribute this, 16x times 4 is 64x, and 16x times negative x is negative 16x squared. And that you can write with your x squared first, and then your x term second. And if you would like, you could put a plus 0 so you have all three terms. Okay, so if you put this equation into your graphing calculator, let's see what happens. So you can bring up your graphing calculator on your computer. And I think this one clears. Second plus 712. Yep. And then if you go to y equals, you're going to type in negative, remember that's this white key at the bottom, 16x squared minus plus, let me move this to the side just so that you can see the equation. That's, oh no! Okay, I guess oh, there we go. Plus 64x. So now you can see both. Now, if you recall, I'm actually going to move this to this side. The x values we need to look at are from 0 to 4. The y values we need to look at go up to 64. So you need to tweak your window so that you can see this graph. So your x minimum can be 0. Your x maximum could be 4. And if you're going to go from 0 to 4, you probably want to count by 0.5 or maybe even something smaller because you want about 10 marks at the bottom where you're counting. And then the y minimum is 0. The y max is 64, so maybe we could put 65. And we can count by 5s. So now you're going to go up and hit graph, and you should get this lovely parabola, which starts at 0, peaks at 264, and ends at 0. If you hit trace, it'll show you your ordered pair numbers. 264 right there is the vertex. So the question to answer, it says, does the graph match your description? And the answer is yes. It is the same. And then it says, when does the ball reach a height of about 58? So if you look at the table, which is second graph, then you're looking for 58. So let's count by a smaller number. So go to second window, which is table set, and that starts at 0. And let's count by 0.5 and see how close we can get to 58. So now if you go to second graph, you'll go back to your table. So see how it's going up by 0.5s? And it's pretty close to 1.5 and 2.5. So maybe we could make it 1.4-ish. If you want to be even more precise, you can go back to table set, and instead of going up by 0.5, you could go up by 0.1. We'll see if we can be even more precise. Okay, so 1.4, that was a really great estimation. So 1.4, and that would match up with 2.6. And we looked at the table on the calculator. And the next question says, find the height of the ball after 1.6 seconds. Well, you can plug 1.6 in for both x's or t's. So you would do negative 16 times 1.6 squared plus 64 times 1.6. But we also have that information right here that you can check yourself with. And 1.6 will give you 61.44 feet. And we should probably put seconds for our units right here. And when will the ball hit the ground? Well, that's when it goes back to 0. So that's at 4 seconds. So, we're going to clear the graphing calculator because we're going to put all 3 of these equations in for problem 4.2. So, second plus 7, 1, 2. So you're going to go to y equals. And you're going to type in negative 16 x squared plus 12x plus 0.2. That is the equation for a frog's jump. The second equation is a flea's jump. Negative 16 x squared plus 8x. And the third equation is for a basketball player's jump. So negative 16 x squared plus 16x plus 6.5. Okay, now if you hit graph, you're really not going to see much at all. In fact, there you go. You got pretty much not much. So you need to change your window so that you can see exactly what's going on. So to figure out your window, we need to look at a table and figure out exactly where the peaks are, where the intercepts are, and what we need to look at. So let's go to second graph. This might still be thinking. Now, as you can see, the frog, let's see if I can write on this, is done jumping already because the frog started at 0.2. That's what this means right here. This is the height of the frog at the start of the jump. That's your y-intercept. Y-intercept means when x equals 0, y would equal 0.2. Okay, so the frog's jump is over after 1 second. The flea's jump is also over after 1 second. And the basketball player's jump takes exactly 1 second. So what's really exciting is we know how high the basketball player will get. Because the minute you have symmetry, you know that the vertex, the peak, is directly in the middle. So let's change this table set and count by 0.5s. So you're going to go to second window. And you're going to count by, start at 0, enter, count by 0.5. So when you go back to your table, you are 100% positive that the basketball player's vertex is at 10.5. So that means since the basketball player starts at 6.5 feet tall, the jump is a 4-foot jump because he gets to 10.5. So he jumps 4 feet at half a second. That's the vertex. In fact, on the next page, or on your same page, it says the basketball player's maximum height is 10.5 feet at 1/2, or you could put 0.5 seconds. And right here, I think it says, how long does each jump last? Well, the basketball player's jump lasts 1 second because that's when the basketball player starts at 6.5 and that's when he ends at 6.5. Otherwise, he'd be like bending his knees. And what does the 6.5 tell you? That's his starting height. That's the y-intercept. So the basketball player is 6 feet, 6 inches tall. That's 6.5 feet. All right, so we're going to go back to the calculator, and we're looking at the table here, and we're noticing that, this is really exciting, the flea has symmetry. So the flea must peak directly in between 0 and 0.5. That'd be at 2.5. So let's change our table, oh my, here we go, so that it counts by 2.5s. So second window is your table set, and hit enter because you still want to start at 0, but now we're going to go up by 0.25. So now we're 100% positive that the flea peaks out at 1 foot high after 0.25 seconds because we have symmetry. And if you trace this back, you'll have symmetry forever. And we're also super excited because we're noticing symmetry here. So we'll come back to that in a second. Let's fill out the worksheet here. So we're going to go to the flea's maximum height is 1 foot. That's pretty tall for a tiny flea of 0 height. And the maximum is at 0.25 seconds, or you could put 1/4 of a second. And so how long did each jump last? 0.5 seconds is how long the flea's jump lasted, because that was when it started at 0 and then it ended back at 0 at 0.5. And then 0.25 was the peak here. And again, the flea's y-intercept was at 0. This is the frog, so we'll come back and explain that in a minute. Okay, so let's go back and look at our lovely symmetry. So we just went up in our table by 0.25, so we need to go up by half of that again so that we can get in between 0.25 and 0.5. So half of 0.25 is 0.125. So if you go to second window, we're still going to start at 0, but now we're going to count by half of 0.25, which is 0.125. So now we are 100% positive that the frog peaks right here, because every other point has a matchup of symmetry. That's how you're positive you have the vertex. Wait a second, I just did a really bad job drawing that. Okay, I'm just going to erase that whole part, but you can match them up. Okay, I'm going to try again. Match, 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 and this one would match back here. Okay, so 0.375, 2.45. So 2.45 feet at 0.375 seconds. And this frog starts 0.2 high, so the jump is really 2.25 feet. So this frog took, well, 0, and 0.375 was the peak. And if you want to go back and look, I'll show you how you can see the other 0. The other 0 being the 0.2, because that's the starting and the ending. So 0.75 is how long this jump lasted. Whoops. So 0.75 seconds. And the 0.2 tells you that the frog starts at 0.2 feet tall. All right, before we answer this last question down here, we're going to go back and figure out on the graphing calculator how we can see the most perfect graph. So, if you're looking to the x min and the x max, we don't need to look at anything past 1. So the x minimum is this number. Okay, this is a bad color to write with. X, oh my. And this number right here is your x max. Now, you're looking at all of these numbers to figure out what your y min and your y max is. Actually, you're not worried about that. You're worried about where the jump ends, so you're looking at all of these numbers. So the smallest y is 0, so that's your y min, and the biggest y is 10.5, so that's your y max. All right, so we're going to go to second, or we're just going to go to window. You don't need a second. So window, and I'm going to erase all that. Oh my. Okay, so the x, we need to go from 0 to 1. So it starts at 0, and it ends at 1. And again, you want about 10 counter marks between 10 and 20. So it'd probably be a good idea to count by 0.1, or maybe even less. And then in the y, we're going to go from 0 to 10.5. So I'm going to put 11 just so you can see the peak. And we can count by ones because there's about 10 marks there. So now when you graph, you're going to see the frogs jump, the fleas jump, and the basketball players jump. And that graph means a lot more than that first graph where you could barely see anything. When you're figuring out numbers, it's very important to have exact data, so you want to use the table. So this last question says, how is the information represented on the graph? Okay. Well, the vertex is all of the max heights, and the y-intercept is where the jump starts and it ends symmetrically the same distance away from the vertex. So I'll pull it back up one more time. So this right here at, I'm going to pull these numbers up so you can see them. So these are all of your vertexes. So the first one is actually the blue graph. Nope, I actually have them. No, yeah, that's right. So at 2 point, because this is 1, so this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Remember how we counted by 0.1? And on the y, we counted by 1. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what I'm talking about, how you want about 10 markers. So the 2.45, 0.375, wait, this is the, I have this back, this is very confusing. This is the x, and this is y. And it's usually the opposite when we write it, but this table has it reversed. So the maximum is at 0.375, which is right here, and it's up 2.45. That's the vertex. This next one is over 0.25, over 0.25, up 1. Right there. And the third one is over 0.5, up 10.5, right there. So that's where the vertex is. And then if you remember the starting heights, this one was at 0.2, so this right here is also 0.2. the flea started and ended at 0, and the basketball player started and ended at 6.5. And this does keep going forever. We just only looked on the graph to 10, so that's kind of why it looks like it stops. Okay, so we're going to do one more mini problem. It's not even on here. I want you to try this and then tell me what you get for your peak. So you're going to clear your calculator. Second. And you know that you've hit second because of this up arrow if you're ever confused. Plus 7, 1, 2. And I will erase all this. And the equation I'm going to give you, oh my gosh, okay, erasing now. Is about the price that this person should charge for jewelry to get the biggest profit. And you always want to clear your calculator so that your windows reset back at -10 to 10, and then you can tweak it how you feel necessary. So your equation is 50x minus x squared. Whoops, I didn't put my x in. So if you hit delete, it deletes the whole thing. If you hit clear, it clears the whole entire line. So deletes just the one number that gets deleted. Okay, so I want to know the best price to charge for this jewelry so that the most profit is made. So the question is, where's the vertex? What's the vertex number? So you're going to use, you could use a graph, you could use a table for sure, and you're going to figure out the exact vertex. And if you're in class, you're going to walk up and show me. And if you're home, you're going to bring it to me tomorrow. That is all.